Hello, today we're going to talk about natural base expressions and how to graph when our base is e. So the natural base e is one of many numbers that are irrational numbers that we tend to use and find in nature. And a famous mathematician named Euler was the one that talked about it most, so that's why they called it e, but it was actually discovered before him. But e can be found with this formula, and it keeps going on. So the next one would be 1 over 1 times 2 times 3 times 4 times 5. And that's not the most important part, but it's just something that it is some number that we can generate. But the main thing that we like to use is just this 2.71828, or just 2.71 is more commonly known. But all calculators have it, and if you have anything online like Desmos, you are easily able to calculate using that. And so we're going to work with a few of this for being able to graph a exponential function that has a base of e. So before we do that, we're going to get into how to evaluate these. And so if you have a graphing calculator, you want to use that. A scientific calculator will usually have this as well as you can use Desmos. But more often than not, if you're using the TI-84, you would press second and then hit the LN button on the left-hand side near 7. And that would give you the E. It will look like E, and then it'll either give you a space up top to fill in, or if you have an older calculator, it will look like E with a caret key like that. And so that's how you know that you're in the proper setting for a calculator. Same with the scientific calculators. If you have a TI-30X2S, you want to hit second, and then there's a button near the top in the middle that has E with the caret key that looks like that. So you want to use that, and then we're going to round to the nearest thousandth. And so for the first one, when we type in e to the fifth, we should get 148.41311591. And rounding to the nearest thousandth, that should give us 148.413. And so that is 2.71828 raised to the fifth power. We just want to use e instead. Do not round the base e, but round the result. E to the negative 3 will give us 0.049787, so that's going to round to 0.050. And then e to the 3.7, when we type that in, that should give us 40.447304. So that's going to be 40.447. And then e to the 5/4 will give us 3.4903992957. So that will round to 3.490. Okay, so just make sure that you watch your rounding and that you are rounding to the nearest place value that they ask you to. Talking about working in exponential equations, so we have f of x equals 3 to the x plus 2. Remember that we have something that is exponential growth if our base is greater than 0, greater than 1, I apologize, and it is decay if our base is between 0 and 1. So knowing that e is roughly 2.71, then if we have a base of e right here, we would say that this should be exponential growth, and it is. You could also graph this and see what it looks like. We have this e to the negative x, so this negative would make this 1 over e, and 1 over e would be like something like 1.271, 1 over 2.71, and so that would mean that would be an exponential decay. So we do have to watch out for negatives or negatives out in front as well. That could cause that. So we're going to graph one of these and kind of show you how we can find some of these. And you will need a calculator, or you can pull this off of Desmos or some graphing calculator. Okay, we have everything exactly the same as before. There is a little bit more information going on up here, and so how we find our x values that we want to plug in is going to be a little bit determinant on what you are using to graph. And so I'm going to graph this without a calculator. If you have a calculator or if you have Desmos, you are able to find these values using Desmos. You are really only going to have one solid whole number x and y point for the majority of these, because since e is a irrational number, then you're only going to get when you raise it to the 0 power is when it's going to be a whole number. But our asymptote is still the same. We're still going to use y equals -2. Our y-intercept, we need to plug in 0. So for our y-intercept, if we find f of 0, we're going to say e to the 2 times 0 plus 2 minus 2. And that is going to give us, let's go to 1 decimal point since we're going to graph. So that's going to be 5.4. And so we have 0, 5.4. And then our domain, it's still an exponential, so it's going to be all real numbers. And then our range is going to go from our asymptote of -2 to positive infinity. And it's not going to include -2. And since e is greater than 1, we should have that. This would be an exponential growth. So to find the 2 points, we've already found 1. So we have 0, 5.4. And to find the other, I want to evaluate the exponent to be, when I evaluate e to an exponent, I want it to be to the 0 power. And so to look at that, I would say, what do I need to plug into x to get that to be e to the 0? And I can plug in -1. And so then that would be f of -1 is e to the 2 times -2 plus 2. And then we have this -2 out here. And so then from there, we can say that this would be e to the 0 minus 2, which will be e to the 0 is 1, minus 2, which will give me -1. Sorry, that's not one, right, negative sign there. So we get -1, -1. And we can graph those 2 points. So we have 0, 5.4, somewhere near there, and -1, -1. So we can see that this does grow relatively quickly. And then we're going to approach our asymptote like that. So it's still an exponential function, just now with a natural base e. So I hope this helps you with understanding a brief introduction to the natural base e.